I'm Sean, Service Manager here at Angstrom Engineering. Welcome to another Angstrom How-To. Today we're going to remove, clean, and reinstall a cold cathode gauge. For most customers, it's critical that they reduce their downtime. And this particular style of gauge may need more simplified maintenance than an ionization or a hot cathode gauge, for example. But because you can simply take it off and clean it in a matter of minutes and then return it to the chamber, the downtime is significantly reduced over sending out an ionization gauge, for example, to be repaired. And that's one of the main reasons we like using this particular gauge. To remove the gauge, we're going to unplug the communication cable, undo the clamp, and remove the gauge from the flange. We'll leave the seal here and take the gauge to the bench to clean. The gauge we're cleaning today is a cold cathode combination gauge. So there's actually two gauges here. There's a Pirani or convection style gauge that measures pressure down to the -3 or -4 millitorr range. And then the gauge changes over to the cold cathode side and measures pressures down into the -9 range if the pressure in the chamber goes that low. So typically where we see this gauge indicates that it needs to be cleaned is that the Pirani portion will measure down in the -3 or 4 range and then the gauge gets stuck. But we know that if we're pumping on the chamber either with the cryo or with the turbo pump, that the pressure should indeed be lower than what's actually being displayed by the gauge or being transmitted by the gauge. This style of gauge is very popular because you can field service it. So you don't have to send it back or send it for repair. You can clean it and it is field serviceable so that most customers can restore the functionality of the gauge simply by taking it apart, cleaning it, and putting it back together. Typically, we can restore the gauge functionality simply by doing what we classify as a quick clean, and that's what we're going to demonstrate today. So we're going to simply take it apart, clean the chamber, and put it back together again. And in most cases, we find that this will restore the gauge functionality. In some cases, on a combination gauge like this, depending on the age, we find that it may need more than just a simple cleaning. And there are parts available to replace some of the other items in the gauge that may be needed to restore the functionality. Once you have the gauge off the chamber, we're going to make considerations for working with an item that's in vacuum. We're going to wear appropriate gloves, long sleeves. Because the gauge has been exposed to whatever you've been using in the chamber for materials, the individual cleaning the gauge may want to make consideration for wearing something like a full respirator or even just a standard dust mask to prevent the inhalation of particulate while we are cleaning the gauge. Most cold cathodes have a very strong magnet. This particular gauge has a warning symbol on it. If you find that you're susceptible to strong magnetic fields, perhaps from a pacemaker, then consideration should be made for your safety in terms of working with the gauge. For us, if customers aren't comfortable cleaning the gauge themselves, they're welcome to return it to us and we'll do the cleaning for them free of charge. If you're considering cleaning the gauge yourself, make sure you follow any internal protocol that may be applicable in terms of health and safety while you clean the gauge. Different gauges may require different sets of tools to disassemble them. You may want to consider following the manufacturer's recommended guidelines for cleaning the tool itself. Most manufacturers will include some instructions on how to clean their particular gauge. Those instructions may be slightly different than the procedure we're going to follow today. However, the procedure outlined here should be quite similar for most standard cold cathode gauges. Okay, here are the tools we're going to use. We've got an Allen key, wrench, circlip pliers, screwdriver, some sandpaper and some Scotch-Brite. We've got some extra Scotch-Brite as needed. Those are the tools that we're going to use today to clean this gauge. Once you've removed the gauge, just be aware while you're working on it of the seal face on the gauge itself. We'll want to make sure we protect that or ensure that we don't scratch or damage that seal face while we're working on the gauge. Let's go ahead and take this gauge apart. The first thing we'll do is remove the electronics. You need to make sure they come off straight. We'll set those aside. The next thing we're going to do is remove the magnet. You'll notice that this is a little bit tricky because the magnet is quite strong. We're removing the magnet primarily because it actually affects the tools when we're trying to work on the gauge. As you can see, it's difficult to get the wrench to turn the bolt because of the strong magnetic field. So for those of you who are wondering, if we're going to clean the inside of the gauge, why are we taking the magnet off? That's why. You can see this is a very strong magnet. So now we have the chamber of the gauge itself. Inside we have a pole piece that we're going to remove. It's held in place by a circlip. We'll use our circlip pliers to carefully remove the circlip. And then hopefully the pole piece slides out. Now we have our gauge chamber with our pole piece removed. You can see the central pin in the middle. We need to be sure that we don't bend that pin while we're cleaning the gauge. And the procedure here is simply to clean the inside walls of the gauge chamber, and then we'll put the gauge back together. We're also going to clean the pole piece as well before it's reinstalled. Typically we use some Scotch-Brite. You can use a couple different things here. Some people will use an Allen key or a screwdriver to push on the Scotch-Brite while it's inside the gauge chamber. I use a screwdriver. We're not too worried about scratching the inside, and basically we're going to work the Scotch-Brite around the chamber without damaging the pin in the middle. So this is the tricky part. We don't want to put any force on the pin. We don't want to bend the pin. We will want to try and clean the pin a little bit. First, we'll focus on just the chamber. You can see I'm sort of bending the Scotch-Brite around the end, or catching the end of the Scotch-Brite with the end of the screwdriver so that I'm cleaning the bottom of the chamber as well. Slide that in. And you just give it a scrub. Now in some cases, the chamber may not look dirty. If we've got some dielectric material inside the chamber that's clear or thin, it could be affecting the gauge performance, but it may not visibly show that it's on the walls of the chamber. So we want to make sure that we polish as well as we can until the inside of the chamber has basically a polished stainless appearance. In some cases, there may be some coloration that sort of provides you with a guide to how well you are cleaning. So in this case, there's a little bit of bluing at the bottom and a little bit of bluing in the corners. So I'm going to try and work that out a little bit more. You can sort of tap out the debris, the particulate. You can see that this is getting a little bit shinier inside. This is the tricky part. We do want to clean the pin a little bit, so I'll usually just fold the Scotch-Brite and very gently clean the sides of the pin inside. We don't want to put any pressure in there. We don't want to put our finger or a tool in there. We just want to gently clean it. You could use sandpaper as well. Scotch-Brite works well. It's very gentle. just basically a plastic cleaning cloth. You can even use a scouring pad like you'd use at home for cleaning your dishes. It's the same idea, works and does the same job. Once we've got the chamber cleaned and the pin polished slightly, we're going to move on to the pole piece. I'm going to set that aside. The pole piece you can clean a number of different ways. Sometimes these are really heavily discolored. You may find that you need to use some sandpaper instead of Scotch-Brite. If you find the Scotch-Brite isn't very effective and it's not coming to a nice clean finish, then by all means use something a bit more aggressive like sandpaper. I like to clean the holes in the pole piece as well. You can roll up some sandpaper, insert it through the holes and just give them a little bit of a polish. They don't necessarily need to be shiny stainless steel clean, but it helps to remove some of the buildup in the holes. Once you're satisfied with the cleaning of the pole piece, then we can go ahead and clean the items and put the gauge back together. At this point, while everything's still a little bit dusty, I would inspect the seal face on the chamber itself to make sure that there isn't any damage. Here we have a few small scratches that I'm going to polish out. We're concerned about scratches that may be a conductance path across the O-ring as it seals to the flange on the chamber. So when we polish, we want to make sure we polish in a circular motion. And we're concerned more about removing any scratches that may be contrary to that circular seal face. So here I'm basically going to just push the gauge seal face or flange into the Scotch-Brite and turn it just to polish it. The scratches on here are quite light and most of them are now gone just from doing that. Next we're going to blow off some of the particulate. You can use a handheld can of air like you would to clean a computer keyboard. We have compressed air, so I'm going to do that. Same for the pole piece. After blowing out the chamber and the pole piece with compressed air, you can consider wiping the surfaces down with some alcohol. And then we'll put the gauge back together. So we'll slip the pole piece back into the chamber body. Reinsert the circlip to hold the pole piece into the chamber body. Then we're going to reinstall the magnet. Once the pole piece has been inserted, you might want to check to make sure that the central pin hasn't been bent or dislocated. It should be centered in the middle of the chamber, and in this case it centers on one of the holes in the pole piece. We've tightened up our magnet. We're going to reinstall the gauge electronics. In this case, we have a small Pirani gauge that lines up with the hole in the electronics themselves. And then we'll secure the electronics with the Allen key. And the gauge is ready to be reinstalled back on the chamber. Now let's reinstall the gauge. First, I'm going to make sure that the seal is clean. the seal face. Reinstall the clamp. We'll tighten the clamp nice and snug. And reconnect the communication cable. That's it. Done. Once the gauge has been installed, go ahead and pump down the chamber and check to see that the gauge is functioning properly. Thanks for watching this Angstrom how-to. If there are any questions or concerns, please don't hesitate to contact us. We're here to help.